Welcome to the DIY Honda Garage channel. This presentation focuses on diagnosing the DTC P0103, which stands for Mass Airflow Sensor, MAF, Sensor Circuit High Voltage. This issue is particularly relevant for the Honda Pilot models from 2016 to 2022. Understanding this diagnostic trouble code is essential for efficient repairs and maintenance. The MAF sensor plays a critical role in measuring the amount of air entering the engine, which is vital for optimal fuel injection and engine performance. A high voltage reading from the MAF sensor can lead to engine performance problems, increased emissions, and reduced fuel efficiency. Addressing this DTC properly will help in ensuring that the engine operates efficiently and meets performance standards. The MAF sensor, or Mass Airflow Sensor, is responsible for measuring the volume and density of the air entering the engine. This data is crucial for the Powertrain Control Module, PCM, to make necessary adjustments to the air-fuel mixture. In the Honda Pilot, the MAF sensor is typically located in the air intake duct, positioned between the air filter and the throttle body. A high voltage condition, indicated by DTC P0103, suggests that something is malfunctioning within the sensor circuit, usually due to wiring issues or a faulty sensor itself. Since the PCM relies on accurate MAF data, any malfunction can significantly impact engine performance and efficiency. Thus, a thorough examination of both the MAF sensor and its connections is essential in troubleshooting this error. The potential causes for DTC P0103 include a faulty MAF sensor, which may send erratic readings due to internal damage or wear. And open water in the circuit can interrupt the signal transmission between the MAF sensor and the PCM, leading to high voltage readings. Furthermore, a malfunctioning PCM can misinterpret normal signals, resulting in inflated voltage readings. Each of these issues can disrupt engine management functions, leading to performance degradation. It is crucial to address these potential causes methodically to ensure a lasting repair. Understanding these elements will guide technicians in navigating the troubleshooting process effectively. Symptoms of the DTC P0103 can manifest as various engine performance issues. You may notice reduced power or acceleration, which indicates that the engine is not receiving the correct air-fuel mixture. Increased emissions could lead to potential failures in emissions tests, as the engine's combustion process is thrown off balance. Additionally, you might observe a drop in fuel efficiency due to the engine compensating for perceived inaccuracies in the air intake. These symptoms could also lead to further complications if left unaddressed. Technicians should remain vigilant and conduct a thorough diagnostics check upon identifying these symptoms. To begin troubleshooting DTC P0103, the first step entails verifying the problem by turning the vehicle to the on position and waiting for about 2 seconds. Next, you must use the Honda Diagnostic System, HDS, to check the voltage reading from the MAF sensor. The key parameter to observe is whether the voltage exceeds the threshold value of 4.89 volts. If the MAF sensor does show a voltage above this threshold, it confirms that the failure is duplicated, allowing you to proceed to the next troubleshooting step. However, if the recorded voltage does not exceed this threshold, it indicates an intermittent failure. In such cases, check for poor connections or loose terminals at both the MAF sensor, IAT sensor, and the PCM. An onboard snapshot of the issue may provide further guidance to reproduce the failure under identical conditions. Moving to the second troubleshooting step, turn the vehicle to the off-lock mode. Using the Honda Diagnostic System, HDS, you need to jump the Service Check Socket (SCS) line, then wait for more than 1 minute. Following this setup, disconnect the MAF sensor IAT sensor 5-pin connector and the PCM connector A, which has 51 pins. The next crucial action is to check for continuity between test points within the disconnected connectors. Test point 1 will be the MAF sensor IAT sensor female terminal number 2, while test point 2 will be PCM connector A, pin number 21. If continuity is present, it indicates that the variable geometry motor, VGM, wire is intact, and you can progress to the next step. Conversely, if there is no continuity, it implies that an open wire in the VGM exists, necessitating repairs before proceeding. For the third troubleshooting step, start by reconnecting the PCM connector A with 51 pins securely in place. Then, check for continuity between test points. The same MAF sensor IAT sensor female terminal number 2 and a solid body ground. Testing in the off-lock mode must be maintained to avoid any electrical issues. If continuity is established, it indicates that the PCM's internal circuit is functioning properly. In this situation, the MAF sensor or IAT sensor would need to be replaced, as it is likely contributing to the high voltage condition. If continuity is absent, further investigation is needed, which may involve consulting authorized service information related to the DTCs or symptoms being addressed. Alternatively, substituting a known good PCM could help determine if the existing one is at fault. After completing the necessary repairs, it's vital to conduct a final repair verification process. Begin by inspecting all connections to ensure that they are secure and free from any corrosion or damage. After confirming that everything is connected properly, verify that the new or repaired MAF sensor operates within the specified parameters. Utilizing the Honda Diagnostic System, HDS, check the readings and ensure they are within an acceptable range. Once verified, clear any diagnostic trouble codes, DTCs, from the PCM. Performing a road test will help confirm that the repair has resolved the issue and ensure that no new codes appear. This final verification guarantees that the repair was successful and that the vehicle is functioning properly. Preventive maintenance plays a crucial role in ensuring that DTC P0103 does not recur in the future. Regular checks of the MAF sensor and its connections should be part of a routine maintenance schedule. Inspecting the integrity of wiring and connectors can preemptively catch issues before they lead to electrical faults. Additionally, adhering to the manufacturer's maintenance schedule is important for optimal vehicle performance. Keeping an eye on potential wear and tear, especially in high-use scenarios, can help mitigate problems associated with the air intake system. Having a proactive approach to maintenance will save time and costs by reducing unexpected breakdowns. In conclusion, comprehending the DTC P0103, which indicates a high voltage condition in the MAF sensor circuit, is essential for effective troubleshooting. The MAF sensor's role in engine management cannot be overstated, as it directly influences fuel efficiency and performance. Thorough testing methods, including continuity checks and verifying integration with the PCM, are important steps in diagnosing the issue. Addressing potential wiring faults and ensuring PCM functionality will facilitate a comprehensive resolution. Emphasizing preventive maintenance practices can significantly reduce the likelihood of similar diagnostic trouble codes arising in the future. By following these guidelines, technicians can efficiently manage issues related to the MAF sensor system in Honda pilots from 2016 to 2022. Please like and subscribe to the channel. See you next time.